Alright, so in this set of recordings, we're going to be talking about some of the basic class of functions that we will be seeing in this class. And the first one is one that hopefully we're quite a bit familiar, and that is a linear function. So a function f defined by the formula f of x equals to mx plus b, where m and b are constant, is well, you guessed it, a linear function. Now, a function is said to be linear if the exponent on the variable is strictly 1. Now, in this case, you see the x. Notice that there is no power here that's visible, and whenever we don't see a power, it's implied to be a 1. Now, if the power is not a 1, then it is known as a nonlinear function. Now, here's a question for you guys. Are horizontal lines linear functions? What about vertical lines? Well, let's see how they look like. A horizontal line is just going to be looking like this. Let's go, let's say that here's a value at 3, and here we have the line y equals to 3. Now, is this a linear function? I think it is, because we just talked about the vertical line test, and if we picture vertical lines passing through this horizontal line, yes, they're only crossing once, so it is a function. Now, what about vertical lines? Now let's go for a vertical line, and same idea here through 3. Now this one is a vertical line, and the equation here is given by x equals to 3. Now, is this one here a linear function? Well, it is a line, but it's still a function. Again, thinking about the vertical line test, how can it be a function if it is itself a vertical line? So this one here is not a function. Something to keep in mind here. Now, let's take a look at one of the most important properties for linear functions, and that is the slope. So the slope of a line is the ratio between the rise and the run. Now, when we talk about slopes, we usually use it to refer to the steepness of a line. As we talked about right now, the ratio of the vertical change, represented here by a triangle. This is known as delta. So whenever you see the delta here, it's representing a change. So delta y is the changing y. Alright, so it's the ratio of the vertical change to the horizontal change. So delta x. So we can think about it as also the rate of change in certain situations. And when we talk about the formula for the slope, or the equation, it is the following: m is equals to delta y over delta x, which is the difference in the y's, y2 minus y1, over the difference in the x's, the run, x2 minus x1. And again, this might be a throwback to other math courses here, the rise over the run. Okay, so let's practice some examples finding the slope. So example 1 is asking us to find the slope of the line that passes through the following points. And let's take a look at the first one here. So we're going to be using our formula. So the slope is given by, let's go with plum. The changing the y's, so y2 minus y1 over x2 minus x1. Okay, now at this point we gotta label which point do we want it to be, the first or the second. It doesn't really matter. We're gonna get the same value. So I'm gonna go with the first point and label it x1 and y1, and the second point x2 and y2. So we're gonna have here, okay, so y2 is 1 minus y1, so minus a negative 5 all over x2, which is a 2, minus x1, which is a negative 1 here. Alright, so what is 1 minus a negative 5? Well, that's the same thing as 1 plus 5, which gives us a 6, divided by 2 minus a negative 1, so it's a 3. So it looks like the slope is 2. And there we go. The slope passing through these points is equals to 2. Excellent. Now, For extra practice here, let's take a look at the nasty looking one. Example C here. So what is the slope going through the point x comma 2x plus 3 and x plus h comma 2 times x plus h plus 3? Now this one here is looking quite scary, but it is really no different to the first example that we just did. It's just that the first example was actually giving us values for the numbers, while the example here is just keeping things in general with some value for x. But if we want to get the slope, we're still saying that the slope is equals to the difference in the y's, y2 minus y1, over x2 minus x1. But in this case, the x1 is the x. This one here, it's still a y value, so I'll call this one here y1. And for our second point, this is x2, and this one here is the y2. So let's put everything into the formula. So we're going to have y2, which is 2 times x plus h plus 3. And in fact, I'll put it in a different color. Let's see, let's put them in green. And the same thing for the x2. Okay, so we have y2 minus y1, which was, again, get into a habit whenever you're subtracting more than one term, put in a parentheses. So that's 2x plus 3. And the whole thing here is being divided by x2 minus x1. So in this case, the x2 is the x plus h minus x. Okay, so we simplify. What do we get? Let's see. Now I'm just going to go ahead and distribute the 2 here. So it's going to be a 2x plus 2h plus 3 minus, well, let's see, let's distribute the negative. So minus 2x minus 3, and it is all over the x plus h minus x. Okay, so I think a couple of things will cancel. On the numerator, I see the 2x cancel here. I see the 3 cancel here. So we are just left with a 2h on the top. Now what about the bottom? Well, I see the x's cancel. So we have 2h over h, which is simply a 2 once we cancel out the h's. Oh, okay, well, at least we got a nice answer. It looks scary at the beginning, but hey, it simplified quite nicely. And in fact, I don't know if you guys noticed it, but this is very similar to the example that we did in the first chapter, or the first section, when we were talking about the f of x plus h minus f of x all over h. Very, very similar, because one thing I didn't mention before is that, well, I guess I'll show it right now. Spoil the surprise here. This was actually the slope. This was the simplification of the y2 minus y1 all over the x2 minus x1. I didn't mention it before, but I did mention that it was going to be crucial to our study of calculus, because the study of calculus deals a lot with the analysis, or yeah, the study of slopes. Excellent. All right, so let's go back to the example here. So let's see. Now let's take a look at another useful formula, and that is the slope-intercept form. Now the slope-intercept form is the following. Y is equals to mx plus b. Now this is the same equation that we saw for the linear function, but now we're ready to talk about the variables m and b. The m in this equation is giving you the slope, and the b is giving you the y-intercept. Now I like this particular form a lot because it is very easy to graph a line once you know the y-intercept and the slope. You don't need to do anything else, and later on we might graph a line, but it's very useful to know the slope and the y-intercept. And let's practice with example 2 here, where it's asking us to find the slope and the y-intercept of a given line. So here we have example A, which is the line 2x plus y is equals to 4. And it's asking us to find the slope and the y-intercept. Now at first glance, it doesn't seem to be in slope-intercept form, so we just set it up in slope-intercept form real quick. And we do that by taking away a 2x for both sides. So we get a y is equals to a negative 2x plus 4. And there we go. Now I get to see the slope right here. The slope is negative 2, and we get to see the y-intercept. So it's going to be 0, 4. And that's it. We are done. Again, the other example B, it's left for you to practice. So now let's take a look at another equation that it's going to come up every now and again, and that is the point slope form. Now the point slope form of a line is the following: y minus y1 is equals to m times x minus x1. Now this particular formula is very useful because it's telling you that, hey, once you know a point and the slope, then you have the equation for a line. Now if you want, you could distribute the slope and solve for y in order to get the slope-intercept form, but in general though, guys, if you just simply write down the point slope form of a line, that's enough. You don't need to go further into the slope-intercept form. Now, why is this equation so useful? Again, it's because all you need in order to get the equation for a line is a point and the slope. And later on, as we're studying more about slopes, we will often be getting the slope, so all that we would need is another point to get the equation for a line. Now let's practice with, let's say, 2 examples with the slope-intercept form. I'm thinking of maybe, let's do A, and actually no, let's do B and C. Okay, so let's see if we can write the equation for the line with the following conditions. The line that passes through the point 1, 3 and 4, 9. Okay, so this particular example is a little bit different because we are given 2 points instead of 1, but we're not given the slope. So the first thing to do is to find the slope with the formula we just saw. The slope is equals to the difference in the y's over the difference in the x's. So we'll get here a y2 minus y1 over x2 minus x1. And that's going to give us here 9 minus, and let's call this one here x1, y1, and x2, and y2. So we'll get here a 9 minus 3 all over a 4 minus 1. So that should give us here a 6 over 3, which is a 2. Alright, so we have the slope. Now let's put everything into the slope-intercept form, which I'll write again here. I'm sorry, the point slope form. So point slope form is y minus y1 equals to the slope times x minus x1. Okay, so we already have the x1 and the y1, and we already have the slope. So putting everything together here, we'll have a y minus y1 being the 3. I'll put it here. I'll put it in green here. And that's equals to the slope, which we got 2, times x minus x1, and there we go. We are done. Now, let's practice with the next one, which, I don't know, might seem harder, might seem easier. because this one is actually giving us the slope. They're telling us that the slope is 0 and the point is 1, 5. So let's see. If the slope is 0, we go again with the point slope form. And I'm going to go ahead and write it again, because anytime that we encounter a new formula, it's always good to write them again so that it's easier for us to remember it. So the point slope form is y minus y1 equals to the slope times x minus x1. Okay, so putting everything in, we'll have y minus y1, which is our 5 here, and that's equals to the slope, which they're telling us is 0, times x minus x1. Okay. So that essentially leaves us with the following. Y minus 5 is equals to 0 times anything is going to be 0. Okay, so there's nothing on the right hand side, which means that I can simply add 5 at 5. So we get y is equals to 5. Oh, okay, well, if we have y is equals to 5, then remember, anytime that we have an equation that's y equals to a number, just as we saw here, it is a horizontal line. Okay, now one thing that I want you guys to remember is that, as we're saying here, if you have a horizontal line, you have a slope of 0. So horizontal lines have a slope of 0. I'll just put here, slope is 0. Okay, perfect. Alright, so this is what I wanted to review for the linear functions. So this is it for this video. See you guys.